Welcome to ETM 260, Computer-Aided Design. This is the lecture number 1, Introduction to Visualization, Engineering Graphics, and CAD. This video is supplemented with the given PowerPoint. Let's start with the definition of engineering graphics. They are a set of rules and guidelines that help you to create an engineering drawing. These rules are essential to make sure that there are no discrepancies between the design, the manufacturing, and the inspection stages in a product development process. On the other hand, an engineering drawing is the method to communicate an idea or design. One of the most fundamental concepts in engineering graphics is the ability to visualize objects in 3 dimensions. The 3 axes are usually arranged in this manner. Notice that the 3 axes always have a positive and a negative direction. An alternative method to confirm the right coordinate system is by using your right hand. Open the hand with the thumb, the index, and the middle finger, as is shown. The thumb finger corresponds to the x-axis, the index corresponds to the y-axis, and the middle finger corresponds to the z-axis. Now you try. An isometric view is a 3-dimensional representation of an object. The main characteristic of this view is that each plane has the same scale. Iso, same, metric, size. The angle between each axis is always 120 degrees. This is the grid, and this is the dot representation for an isometric view. In 2-dimensional CAD, the main tools are point, line, polyline, arc, circle, spline, rectangle, and polygon. The idea is to use this tool to create 3D objects and for the user to be able to visualize them successfully. In 3-dimensional CAD, the main tools are cylinder, sphere, cone, ellipsoid, box, and torus. All these are derived from the 2-dimensional tools that we just mentioned. It is important to understand the type of lines that are used in an engineering drawing and how they are used. Let's start with the visible lines. They represent visible edges or boundaries. These lines are continuous and thick. The hidden line represent lines or edges that are not visible. They are dashed and medium thick. Central lines represent axis of symmetry of an object. They are a combination between a long dash, short dash, and a long dash. It is very important to use central lines to represent cylindrical shapes. For example, looking at these objects from this view, user cannot tell whether it's a box or a cylinder. The only way is to add a central line to show that indeed is a cylinder. There are multiple methods to represent a 3-dimensional solid. One of these methods is the wireframe modeling. This method shows only the edges of the model as solid lines. Notice that in some instances the wireframe model does not show all the curved features of the model, as is shown here. Therefore, caution has to be taken when using these models to make sure that all the features are properly accounted for. The orthographic view is a 2-dimensional representation of an isometric drawing. The name is derived from ortho, 90 degrees, graphic, drawing. The orthographic projection has mainly 3 views, which are always aligned in an L configuration. At the corner of the L always is the front view, in the upper edge is the top view, and in the right edge is the right view. Let's now learn how to convert an isometric object into an orthographic projection. This is done by using the 6 principal views: top, bottom, front, rear, right, and left views. These views are created by looking perpendicular to the surface. This is like taking a picture straight on, looking into each of the surfaces. The method that is used is the glass box method. The following are the steps taken to create the 6 principal views. The first step is to place the object inside of the glass box. The idea is that each side of the box represents one of the principal views. The second step is to project all the object surfaces, which are the projectors, to the glass planes, which are the projection planes. Notice how all the surfaces are visible in the projection planes. Be careful when projecting inclined surfaces. For example, this object has an incline that projects in the front view. However, the right and the top view only shows rectangles. The third step is to unfold the box, which shows all the principal views. The fourth step is to show all the 6 principal views organized in a standardized form. The front view is the most important view, therefore remains in the middle, although the 5 views are aligned as shown. Let's now utilize the method to create an orthographic projection of this object. The first step is to create the front view using only visible surfaces. Then create horizontal and vertical projection lines. These lines will help you to determine the size and the location of the features in other views. Let's now create the top view. Using the projection lines, draw the visible lines of the top view. Notice that in this case, there are 2 projection lines that are not visible in the top view. Therefore, you need to use hidden lines to represent these features. Once you are done with the top view, create projection lines of the features that were present in the top view and not on the front view. Then add hidden lines into the front view. In order to create the right view, it is necessary to create a 45-degree projection line from the upper right point in the front view. Then create horizontal projection lines from the top view to the 45-degree line and continue with vertical projection lines. The intersections will indicate the size and the location of the right view. Add solid lines to visible features and hidden lines to non-visible features. Make sure to add center lines when necessary. The top view shows a circle, so add a horizontal and a vertical center line. Each center line must be paired with one in other view. For example, the vertical center line goes with the one in the front view, and the horizontal center line goes to the one in the right view. The following are very important things to keep in mind when creating an orthographic projection. The distance from the front view to the top view must be exactly the same from the front view to the right view. The vertical size of the top view must be exactly the same as the horizontal size of the right view. The 3 views must be arranged in an L format. Once you are done adding all the details to the views, you're done with the orthographic projection.